First, I'm going to argue that hyperobjects are foreshortened in time. Einstein's discovery of space-time was the discovery of a hyperobject, the way in which mass, as such, grips space, distorting it from within, stretching space and time into halls and vortices. For Einstein, entities, which may or may not include living observers, comprise indivisible world tubes. Each world tube encounters a fundamentally different universe depending on its mass and velocity. By world tube, relativity theory means to include the apprehending aspect of an entity with its entative aspect. A world tube is a hyperobject, that is, world tubes stretch and snap our ideas of what an object is in the first place. But not only our ideas, world tubes recede from other world tubes in an inescapable and irreducible way. There are two main reasons for this. One, light rays bouncing off an object only exert an influence within what Hermann Minkowski, the mathematician who proved relative theory geometrically, calls the light cone. There's an absolute past and an absolute future relative to any reference frame, a concept that approaches Derrida's idea of l'avenir. Relativity limits prediction to the light cone. That is, for every object in the universe there is a genuinely future that is radically unknowable. There is a genuinely elsewhere that is radically unknowable. Yet the future and the elsewhere exist. They are, in my terminology, strange strangers, knowable yet uncanny. 2. When we examine a world tube up close, it has all kinds of strange properties. This is because time ripples and melts along its surface, so that sensual interactions between one tube and another tube are always melting and dripping, rather than rigid and uniform. Thus time and space aren't physically real. Rather, physical events are real because they contain time and space in their interior, an argument of Einstein's that Graham Harman does in another way. Only infinitesimally small areas of space-time may be regarded as Galilean, that is, as rigid and container-like. The Einsteinian object isn't a unity at a small enough resolution, for instance. Thus, it is not possible in relativity to obtain a consistent definition of an extended rigid body, because this would imply signals faster than light. That means that the pencil you are holding in your hands is only a rigid extended body on account of a false immediacy. Nothing in the universe apprehends the pencil like that, really. Not even the pencil apprehends itself like that. The physical universe consists of objects that are more like turbulence in a stream than gooey or hard, extended bodies. A world tube, with its irreducible past and future, is a withdrawn object. Relativity positively guarantees that objects will be forever withdrawn from any object that tries to access them, including those objects themselves. And general relativity gives us the most obviously withdrawn object of all, the black hole. Hyperobjects envelop us, yet they are so massively distributed in time that they seem to taper off like a long street stretched into the distance. Time bends them and flattens them, the same way that an electromagnetic wave front actually shortens at its leading edge. Hyperobjects are foreshortened in time, just like objects in a perspective painting are foreshortened in space. Because we can't see to the end of them, hyperobjects are necessarily uncanny. Like the empty streets and open doorways in the paintings of Giorgio de Chirico, hyperobjects seem to beckon us further into themselves, making us realize that we're already lost inside them. This recognition of being caught in and by hyperobjects is precisely a feeling of the Freudian uncanny, a feeling of strange familiarity and familiar strangeness. We already know the weather like the back of our hand, but this is weird weather, this global warming weather. We already know light, but this is weird light, this radiation. Levi Bryant, exploring hyperobjects in a recent blog post, describes it thus. Hyperobjects are thus like our experience of a pool while swimming. Everywhere we are submersed within the pool, everywhere the cool water caresses our body as we move through it, yet we are nonetheless independent of the water. We produce effects in the water like diffraction patterns, causing it to ripple in particular ways, and it produces effects in us, causing our skin to get goosebumps. Space can thus no longer be construed as an absolute container, but as a space-time manifold that is radically in the universe, of it, rather than ontologically outside it. Space-time turns from a grid-like box into what Einstein fantastically calls a reference mollusk. Reference mollusks exist precisely because of hyperobjects that emanate gravitational fields. In these fields, geometry isn't Euclidean. In an age without computer graphics that could morph a grid into rippling, swelling hollows and bumps, Einstein turns to the most squishy thing he can imagine. But I rather think we should bring back the mollusks. Hyperobjects aren't infinitesimally small, thus they have Gaussian coordinates rather than Euclidean ones. Hyperobjects are time-squished. To this extent, H.P. Lovecraft's Cthulhu is a hyperobject, a giant squid-like being floating asleep in a non-Euclidean realm out there in the universe. Our ecological devastation has summoned these Cthulhu-like hyperobjects to terrorize us. Like all objects, hyperobjects compel us to handle them in certain ways. They exert what Alfonso Lingis calls the imperative, but because of temporal foreshortening, hyperobjects are impossible to handle just right. This aporia gives rise to a dilemma. We have no time to learn fully about hyperobjects, but we have to handle them anyway.